now we'll have to just see what is a couple. Before going to this technical meaning of this couple, in general we mean a couple means two dissimilar forces, but that should be parallel. The meaning is, if I have considered a body, I mean this is a rod, I take one force which is acting in upward direction, another force which is acting in upward direction in other end, say suppose end A and end B. This is just, I can add these forces. Force A, suppose this is 10 Newton, and at point B another 10 Newton, say as example, it becomes 20 Newton. That's what we have studied. A couple is a meaning, couple means I should have two forces, but it should be parallel to each other, and the nature of the force should be opposite in direction. I have two forces, it cannot be more than two forces. First condition is, to form a couple should have two forces only, and the two forces should be parallel to each other, but its nature should be in opposite direction. In the sense, this force is acting towards upward, the other force which may be drawn anywhere, depending on the distance or any point, it should act towards down. Okay, this is one diagram. The second diagram I can indicate same parallel forces acting in opposite direction. I can take one force is acting, at point B upwards, at point A I should draw it at downwards. At point A, if I am trying to draw a force which is up, this again will not form a couple, because couple is the one which should have a direction in opposite sense. See, in this diagram I indicate at point A force is acting up. Again, the one more force which is in any point which should act parallelly but in downward direction. That means the sense of action is opposite. That's very important to form a couple. That's meaning of couple is this. You have two forces which is parallel to each other but acting in opposite direction. Okay, it cannot be in the same direction. So I should change this diagram. In what way? This is acting upwards, the other force should act downwards. Right? So this makes a couple. So force couple system, what we have to study now. Actually force, we already known this, force an unit of Newton. The couple is the one, you have two forces, again its unit is Newton, but when you have a couple, you will have some distance between two forces, right? If I take this point A force, suppose 10 Newton is acting, and just an example, other one some 2 Newton is acting, right, at different points, but you should have to contain a distance between these two forces. Say suppose I'll take it as A, and this particular distance is taken as, why it is A, and it is called arm of couple. Arm of couple means you have a body, in this you have two forces are acting which is in the opposite, parallel to each other, but it is opposite in nature, and this distance between two bodies, forces, is taken as arm of the couple. See, this is not a technical word, it's just a normal word, where arm in the sense there is a distance between 2 points where a force are acting. So this is A denotes arm and force 1 and 2, and the purpose of writing this diagram is to see that this will give a twist moment. Normally a force is applied to either in, again I repeat, we will go back to the previous steps, it is right hand direction, left hand, top or bottom, or in inclined direction. The purpose of learning couple is to see that a twisting force for a body, say for example I have this chalk piece, the length of this say some 5 centimeters. If I have a force like this acting from the top, other force acting from the bottom, what will happen? It will twist. When a twisting force is given, it can be possible with couple. And couple is defined in terms of considering only two forces, not more than two forces or not less than two forces. Right? So this couple is learnt, the force couple system is learnt to see that how a body is being twisting or the body is being acted upon by the twisting force. Normally we have a force, vertical force, horizontal force, inclined force. Apart from that, we have a force known as a twisting force, which is known as a coupled system. Right? Now this is the first step. And when you go to second step, for example, let these figures as it is, 1 and 2. I'll just consider a force. Right? A force is there with any direction, say F. I need to know that how can I convert this force into a coupled system. In the sense, I'll just take a body, okay, a force is acting in this body. Say this is a body, a force is acting, suppose this force is F, and this point is A, length of the body is A, this point is O, a force is acting here. Now I need to convert a single force acting on a body into a coupled system. A force is being converted into force coupled system. How to make it now? A force is acting on one point. A couple, to make it, by nature the couple should be parallel to the previous force, but opposite in sense. Is it not? Yeah. So I need to just indicate a couple by indicating a force towards downwards, which makes the body rotate in clockwise direction. We shall say this clockwise couple. Clockwise couple. This couple may be either in rotation in clockwise or in anti-clockwise also. This shows my clockwise couple. This is sketch number 3. Sketch number 4. Same fashion we can indicate a anti-clockwise couple. How is that? This is again a body. One force is acting like this, other force like this. What will happen here? Again it makes clockwise. Clockwise couple in like this. Anti-clockwise couple. How is anti-clockwise? It cannot be anti-clockwise because this force is again the same. It will rotate the body in clockwise direction. Now there is two forces acting in different directions, opposite sense, but they are parallel to each other. In this we can prove that the forces acting on a body, say suppose one force is vertical and one force is, one is acting down, one is acting up. If we consider a point in between these two forces, say suppose this point is O, and take a distance of between two forces, this is F and this is again F. Okay, this is F1, I say it's F2. Okay, and this distance, the total distance of this body, length of this rod is suppose A, and the distance from force 1 to point O is X. Right, now I will write this force F1 into X. This is for a moment about say point O. I will write F1 into X, perpendicular distance. What about this force? I will write moment about, say suppose this is point A. This is A, F2 is acting here, F2 into, about this point O is again, this is X, this is also X. Okay, fine. So again F2 into X. So both are F1 into X or F2 into X because we are just considering two forces in different edges and we are taking moment about one point, 2 points center. If I take a moment about point A, which is here, what will happen? This F2 into the distance is 0. I repeat again, force means my moment is force into perpendicular distance. No distance here to 0. What about F1? So here, if you consider force F1, F1 into this arm A. Right? So this couple will just give a twisting moment for a body. It will twist in any direction, but you will have to consider two forces which are to be in parallel to each other but opposite direction. That is very important. So couple is the one, apart from your directly a vertical force, a horizontal force, an inclined force, this is, apart from that, it gives a twisting moment. So this is also a one point, a part of force which will give or apply to a body, which we have to consider and analyze to keep the body in equilibrium condition. If we solve one or two problems in this, how to converting using the numbers, the problems using the digits or the values, if we are learning to convert, how do we convert a force into coupled system, you will better understand, right? So the purpose of this is to see that analyzing the twisting force, it gives a twisting moment. We are going to analyze the twisting forces also, so that the body is in complete equilibrium condition, right? And now what is a couple and what is force coupled system, I will explain. Here this is a rules for converting a force into a coupled system. Force is a single force. How do we convert into a coupled system? Couple means it should be two forces minimum. So resolution of a force into a force and a couple at a point. Okay, so this is this topic, and there's an example I'm just written here. We will come, I'll explain next. Now here to see how do we resolve or resolute a force into a force and a couple. I'll just highlight this. A resolution of a force, a single force, which is changed as a force and a couple, right? Now consider this point A and B of a rod, which is the distance of small a. A force is acting, so suppose this force is P. In the next sketch I have shown, okay, this force remains as it is, right? Force is as it is, the distance is A, point B is in the other end. Now if I introduce two equal and opposite collinear forces, these two are collinear means in the same line of action is same. Two equal and opposite collinear forces which are equal in magnitude also. So for example, this is 2 Newton, again 2 Newton. So it gets cancelled, is it not? Two equal and opposite collinear forces, which means if you write this or if you don't write it, the value is same. The difference between sketch number A, or I can write this is sketch number B and this is C. Okay, sketch A shows only a force acting at point A, okay, and point B is free. The distance between A and B is small, this is arm A. And sketch B, it shows I'm just replacing one force already available, and in opposite direction I'm introducing the same magnitude, the value of the force which is already available in two different places which are opposite in nature, and though both are collinear forces. So if you draw this or not, the effect is same, because these both get cancelled. The remaining one is the force which is from the beginning. After this sketch number 2, we are trying to just resolute one force into, try to change a force into a couple system. To make a couple, we have already known what is a couple means. It gives a twisting. Couple means you should have two forces which are parallel to each other but opposite in the direction. Now here, if you just since this force is not considered, what happened to this now? Two forces are there which are in different directions. It's parallel to each other but in the different directions, which can form a couple. Previously what we have seen is this. Now if with this effect of this force also, the value is same. So here I indicate this force P and the other one P down, which are parallel to each other but different in direction, which will form a couple. Means the remaining one is this force. All on the same magnitude, value is same. So this is indicated by this P. This force P is indicated here. The other two forces of P which is acting up and P which is acting down at point A and B differently, consecutively, that will form a couple. This couple is indicated by this symbol, which shows it's clockwise. If we want to make it anti-clockwise, say suppose example, if this force is drawn here and this is kept empty, we can draw these setup in the opposite side and make it anti-clockwise couple also. It's possible. So this is a clockwise couple which shows moment is equal to force into distance. What is this force? This P into distance. So couple is, unit is what? Unit of couple is kilonewton meter, or it takes Newton meter again. Couple is force into again distance. Force is Newton and distance is meter. Either you can take as kilonewton or in terms of Newton meter. So this is how you convert a force into a force coupled system. The purpose of this is to see that, again I repeat, it is a twisting moment. If we analyze the twisting moment along with your vertical, horizontal and inclined forces, we will balance a body in perfect equilibrium. Now just a question here. Example, how to replace the force of 20 kilonewton, it is shown in this body. Okay, this body of a beam or a rod with point ABC. At point B at 20 kilonewton, force is acting downwards. How to replace the force of 20 kilonewton acting at point B into force coupled system at A. The force is acting at point B only. We have to reduce it into a force coupled system at point A. That is the condition. How to do it now? The same procedure is followed here. So first we are drawing this sketches as it is at point A. Now our work is to introduce another two forces which are collinear, but it should make the same effect in a point, so that with the applied value of 20 kilonewton and the other force, it forms a couple. For which I do, when it is asked that it should be made, the couple system is made at point A, not at point C, because we have 2 points A and C also, and point B only the force is acting. So I'll just take the force here. We will have to keep the 20 kilonewton, okay, as it is, right? So we need to consider only the point A and B, because C is not required, because the applied force is at point B and the coupled system is to be converted at point A only. So we can just even draw only this distance of 20 kilonewton, and this distance is how much? 3 meters. Of course there is 3 meters as well as 2 meters are given, but the question, it says we have to show a force coupled system is made at point A only, right? Now this is point A and this is point B. Now what we have to do, with the same fashion of this resolution, I am introducing this one force acting downwards, right? When a force is acting upwards here, in the opposite edge we have introduced two forces which are collinear, opposite to each other nature. But what will we do it here? We have to introduce two forces which are collinear, opposite to nature. So I will introduce two forces which will be collinear and opposite in nature. See, either it should be this kind, which is going towards, no, away from the body, or it's towards the body. Okay, you cannot make a force acting in the same direction. In the sense, I cannot divert this arrow mark which comes down, which cannot form a couple, because couple means it should have a twisting moment. Say suppose if I introduce a force like this, what will happen? It will not form a couple, because this 20 kilonewton should give an effect so that it makes a couple. So this is 20 here, this is also 20 here. At point A it should form a couple. That is why the arrow marks are like this, and it is collinear forces, both are in different directions. So now if I close this value of 20 kilonewton, this 20 kilonewton which is acting down and 20 kilonewton acting up, the magnitude is the same, which will form a clockwise couple at point A. Now what to indicate? In this fashion it will indicate this 20 Newton as it is, and I indicate a couple like this. Okay, how is this value? That means I have drawn this picture is equal to this. I have converted this sketch into third sketch. This first one given one, second one and third one. This point is A. Okay, now here this 20 Newton remains as it is written here. This 20 which is acting downwards and the other opposite 20 which is acting upwards forms a couple. So this value should be indicated about what? The moment is force into distance here. Force is P, the distance formed is A. Some value it is. Like this, the force is 20 kilonewton. What is the difference distance formed here? 20 into 3, it is 60 kilonewton. So it is 20 kilonewton into 3 meter. It becomes 60 kilonewton meter. That is my value. That's my couple. So this is the sketch of 20 kilonewton. The force of 20 kilonewton acting at point B is converted into a force coupled system at point A by this way. The use of this is to reduce the work or make the complex problem simpler, so that we can easily just add up this value. So why? Because we find out the resultant, what we are doing, either we are adding up if the force is up or down. This is a couple which shows clockwise and anti-clockwise. If it is a clockwise couple, you can directly add it. You have to multiply with the value, because it is already multiplied with the length of the rod where it is acting. If it is clockwise couple, you have to add it up. Anti-clockwise, it is negative. That's it. And this is the answer. The answer is you are converting a couple, a force, into a force coupled system at point B. For example, if it is asked, so this is only one point here. Say for example, it is asked to convert this force coupled system at point C. Okay, kindly remember, I have changed this point C. This one answer at point A is over. At point C, how do I do it? You will have to forget about this A. The B and C remaining. You draw a sketch. This is point B, 20 kilonewton acting, and point C is in the right hand side. Opposite again, I have to form a couple. How? This force should have an opposite value, and the same thing. I will just indicate like this. Simple. 20 kilonewton and 20 kilonewton. At point C is this. This will form what? An anti-clockwise couple. That is the difference. Now you close this, just see that this is not considered. This is from an anti-clockwise couple at point C. Now what to indicate? Like this it is. I have to keep this value of 20 kilonewton as it is and indicate an anti-clockwise couple. Value is this 20 into this meter is, it's 2 meters, because B to C is 2 meters and A to B is 3 meters. It's given in the problem. So it's 20 into 2 is 40 kilonewton. So this should indicate this moment is 20 kilonewton into 2 meters, which is known as 40 kilonewton meter. This is the value. So this will be helpful while calculating the forces. We can use it in terms of just either to add it up if it is clockwise couple, or subtract it if it is anti-clockwise couple. That's it. It's a simple way of reducing the complex problem into simpler one. Right? If we solve 1 or 2 questions like this, it will be easier for you to understand. And you need to practice with the number of questions given in the textbook or reference book.